This little video is going to be about talking about going to infinity and determining whether or not we can find answers at infinity for our limits. There's two things that we're going to be looking at in particular, and it's the graph of a constant function and the graph of a rational function. And we're going to show you why those two things are so important to us in calculus, and then we'll just end it off with a non rational function example as well. So first of all, we're looking at a couple of constant functions. We got f of x equals 3 or y equals 3. And what we want to talk about again is what number are you approaching as you get closer and closer to infinity. And this is kind of your basic idea of a limit anyways. If you come from the right side or left side of a constant number, the limit's always going to be that constant. So when you graph a constant, it doesn't matter where you're on the line, the answer is that number. So no matter where you are on this function, infinity or at 0, the answer is going to be the limit's going to equal 3. And if you change that to graph y equals 4, f of x equals 4, the limit at infinity is going to be 4. So graphing constants is actually kind of a pretty key thing that we have to look at in calculus because the constant doesn't change. And sometimes things not changing is as important as things that do change. The next thing we want to look at our rational functions in a fairly basic form. So y equals 1 over x. Again, this is a function that's defined everywhere except for where you're having divided by 0, so not defined where x equals 0, but it's continuous to the left and to the right of 0. And again, what we want to look at for the visual part is what happens as your x value gets closer and closer to infinity. And we can change that to a graph of y equals 3 over x or 10 over x, but the key thing is that we are dividing by the function of x. Again, what's happening as you go to infinity? If we change our function, the next one, if it's 1 over x squared, a little different looking graph, but we're still looking for what's happening as you're going to infinity. And then if we even put a stretch into this as well, what happens if it's 50 over x squared? And if you put all four of those graphs together, you start saying, what's the pattern? What is it that you're approaching as you get closer and closer to infinity whenever you graph a rational function? And these are rational functions in their basic form. It's a constant in the numerator and x to a degree in the denominator. And hopefully what you're seeing is you're seeing what's happening, and this is only as far as 15. We're not even close to infinity. We're not even at 100 or 1,000 or 1,000,000. But as you can see, it doesn't matter which one of our four functions we graph. As you get farther and farther to the right, your function gets closer and closer to 0. So that is so important to us that we need to know how to put zeros into our rational functions. Because if you go to infinity, you either want to be dealing with constant terms that don't change, or you want to be dealing with rational functions that are zeros. And the reason for that is if you look at a quadratic function, this is x squared, I think, plus 4x. If you start thinking about what number are you approaching as you go closer and closer to infinity, well, you don't approach a defined number. I mean, the larger the x value is, the larger the function value is. So there's no defined answer when you go to infinity for linear functions or quadratic functions or cubic functions, anything like that. So we really want to focus on our skills of working with constant functions and working with rational functions, and how do you take and apply those things then to go to infinity for more complicated functions. So that's a quick intro to some of the skills we're going to work with. The next thing we're going to look at then is some actual examples of rational functions.